Okay, Charles, I'm going to see if I can get you to derive a piece of the temporal difference equation just by working through this example again in a slightly different way. So from the last thing we talked about, we said that the value estimate for S1 after 3 episodes was 5.
Mm-hmm.
And then we ran an episode, and the return of that episode, the sort of the total discounted reward for that episode, episode number 4, starting from that state S1, was plus 2.
Mm-hmm.
Could we, just from this information, figure out what the new estimate's going to be?
Sure.
So let's see if we can do that. Let's work through that step by step.
Oh, okay. Well, I can cheat, right? You have everything indexed by time, so I know that 5 is an estimate of the last 3, and 4 is an estimate of the fourth one.
Right.
So I should be able to, weight the first one with 3 and the other one with 1 or something like that, and that'll give me the right answer.
All right. So what do you mean by weight? So what you mean is, since 5 is the average of the first 3 episodes,
Mm-hmm.
then 15 is the total from the first 3 episodes, right?
That's right. I've seen it 3 times.
Good. It's as if we had seen 5 3 times. Though the details actually varied from that, but that's okay because averages work out nicely.
That's right. Doesn't matter.
Then we got an additional reward of 2,
Mm-hmm.
and now we want to know the average over 4 steps, right?
Mm-hmm.
So that gives us 15 plus 2 divided by 4 is 17 over 4, which is just the answer that we had in the quiz.
In fact, that's exactly how I did it. I just took the 15 over 3 that you had written down and just said, oh, so that'll be 17 over 4.
Good. So now let's generalize this a little bit and put in some letters because, math. So
Okay.
let's say instead that we're talking about the previous estimate, which was from time t minus 1. Then we get a return on step t of t, and now we want to compute the new estimate vt of S1. So we should be able to do that same kind of calculation with these quantities, just symbolically. Okay, so you want to try that again?
Sure. So I think I know what Vt of S1 is equal to t minus 1 times V sub t minus 1 of S1 plus R sub t of S1 divided by t.
Good, which was 4 before, but now in general it's t.
Mm-hmm.
Excellent. All right, so let's now do a little bit of algebra on this.
Oh, sure.
So first I'm just going to divide through by this capital T and split it into 2 pieces of the sum.
Okay.
All right, and so then we can regroup things as follows. Let's see. So I guess mainly the idea is that we split this t minus 1 over t into a t over t and a minus 1 over t. So that gets us vt minus 1 of S1 plus 1 over t of RT S1 minus VT minus 1 S1. So I wrote it kind of funky. I introduced this additional learning rate parameter alpha sub t, the learning rate at time step t, but it's really just playing the role of 1 over t here, the averaging. But there's an interesting thing that popped out of this particular way of rewriting it, in that we are looking at a kind of a temporal difference, that our update to the value is going to equal the difference between the reward that we got at this step and the estimate that we had at the previous step. And so this difference is actually going to drive the learning. So if the difference is 0, then things don't change. If the difference is big, positive, then it goes up. And if it's big, negative, then it goes down. And as we get more and more and more episodes, this learning rate parameter is getting smaller and smaller and smaller. So we're making smaller and smaller changes. We're kind of honing in on the actual true value.
So this actually looks just like the update rule for perceptrons.
Yes. And in fact, that was, I believe, what Sutton was trying to do. He wanted to make temporal predictions, and he wanted to put it into the same kind of algebraic framework that people were familiar with from perceptron learning and from neural net learning.
Right. So if we did that way, then RT minus V sub t minus 1 is the error.
Very good. Yeah, that's a great way to look at it, that we're making our update based on moving a little bit in the direction of the error.
Right. Moving less and less and less as time goes on, which is just what you're supposed to do with the learning rate.
Exactly.
So let me ask a question along that line then. So along those lines then. So if alpha sub t was not 1 over t but something else, like, I don't know, 1 over the square root of t, or I don't know, something, some other way of doing the learning rate, you would get a slightly different answer. Would you expect at any given time, but would you expect to kind of converge to the same answer ultimately?
That is a really good question. In fact, that was the next question that I was going to ask.
Oh, wow. I feel better now.
So here it comes.